Okay, so now we're going to talk a little bit about vectors, and then we're going to move on to talking about sets of vectors that make up tables which we call matrices. So the first thing that we've learned earlier is that we can describe a complex number in terms of its real and its complex part. And so when you draw out a graph, you can have the real axis here and you can have the imaginary axis here, and this here is our imaginary point z, and that's equal to the real part plus the imaginary part, and we usually denote that a plus ib. So that's nice and straightforward. And we also learnt that the mirror image of this is the complex conjugate, and that has this symbol here, this little asterisk, and that is the real and it's minus the imaginary, and so the form of it is a minus ib. And then when you multiply these two together, you'll actually end up with a real number. But I'll just let's just think about this point z in a bit of a different sense. This point z, you can think about this as a vector which goes from the basically an arrow that goes from the center out to the point. Okay, and we call these arrows vectors, and there's a few things about vectors. The first thing is that they have magnitude and direction, and this is the most important thing about them. They have a length, and they have some sort of direction associated with them. So let's have a think about how we can represent a vector. So let's draw a graph, and let's say that this point here we want to represent as a vector, and so we'll draw a line from the that wasn't a very good line out to that point, and this here is our vector. So its length we can denote as r, and this kind of makes sense, kind of the radius, you can kind of think about it almost like that. And then we can think about an angle that it has from the x-axis, and this tells us the direction, and this here tells us the magnitude. There's a few rules to do with vectors, and basically they have their own algebra. So what do I mean by that? So what are the rules for adding two vectors? So let's say I have a vector like that, and I have a vector like this. When I add those two vectors together, I add the head to the tail. Head to tail. And so this here is the head of this, and this here is the tail of this arrow. So when we add them together, that goes to there, and then the tail goes on to the head there, and we can write the sum of those two as this green vector here. Okay, so that's quite useful. The other thing we can do with vectors is we can decompose them. So we can decompose into components. What do I mean by this? Well, if you think about this a vector in the xy plane, and we've shown earlier that you've got r and you've got theta, we can think about this as being made up of two vectors, one along the x-axis and one along the y-axis. And using our rules of vector algebra, we can add x to y and we'll actually get this vector r. So if we do this, this is our x, and we add that to our y, we will get x plus y, and we'll get back our vector r. So how do we do this? Well, we can just simply use our rules of trigonometry in order to work out the components of this. So this is the opposite here, and so this is going to be r sine of theta, and that's going to be equals our x component of the vector r, and this of the y component, and the x component will be r cos of theta, which is equal to rx. And now what we can do is we can write this in the form r is equal to rx plus ry. The other thing we can do is introduce something called the unit vector. And the unit vector is something that has a length of 1, and it goes along the x and the y axis. So along the x-axis we're going to introduce something called the unit vector, and usually that's denoted with the symbol I hat, and along the y-axis you've got j hat. So these have directions, so that's the important thing. They have directions. Oh, that's bad. And they have unit length. And what we can do then is we can get rid of the the direction part of this. And probably I should say that usually when we denote a vector we put a line above it. We also can put a hat above it. There's different ways of describing a vector. But yeah, the hat just means that it's not just a length, it actually has a direction as well. So at the moment we've got r, and that's a vector. We've got rx as a vector and ry as a vector. But what we can do is by using this unit vector, we can take out the directional aspects of this, and so we will just have rx times I hat plus ry times j hat. And now we've got two magnitude numbers, just numbers. These are just magnitudes, and these here are directions. Okay, and so what we've done is we've decomposed the matrix into magnitudes and also into directions, which is really really useful. And this is basically what we do with imaginary numbers. We can decompose an imaginary number into its real and imaginary part, and then we add them back together, and we get the vector, which is our imaginary number. So the next thing we're going to go into is talking about how we deal with lines and with putting together vectors into tables, and we call these tables matrices.